Sam.
And my name is Asher.
I'm a senior at Odyssey Leadership Academy.
I'm a sophomore here at Odyssey Leadership Academy.
All the information that you are about to hear was taught to us by our mutual Oxford colloquium class.
And our mutual Neuroscience of the Mind class.
But today, we are going to be the teachers.
Speaking of teaching, did you know that music is one of the first things that gets cut in a budget cut in public schools?
Yeah, actually just a few months ago, the Oklahoma City public school system just took out over 20 bands and orchestras due to the recent budget cut.
I guess they think music isn't that important.
Well, that's what we're going to have a little talk about. Cool. Did you know that when you play a musical instrument, that fireworks start going off in your head? When looking at a musician, though they may seem calm, they actually have fireworks or a very exciting activity going off in their head. How do we know this? Over the past few decades, neuroscientists have made amazing breakthroughs when it comes to understanding how our brains work by learning from functional magnetic resonance imaging, or better known as fMRI. How an fMRI works is that it uses special magnets to detect blood flow in the brain and then displays the image on a screen. Neurology tells us what the functions of the very specific parts of the brain, so that when a subject is hooked up to an fMRI and then asked to tie a shoe or read a book, the corresponding section of the brain to these tasks light up. When you tie a shoe or other similar tasks, you're using your built-up myelin, which we'll talk about later, and muscle memory. These functions are corresponding with your cerebellum, which on the screen is the brown section labeled 14. Whenever you read a book or other similar tasks, you are using your other built-up myelin that allows you to read that book. This function corresponds with the Wernicke's area located in the dominant temporal lobe, which on the screen is the pink section numbered 11. But when a subject would listen to music, the neurologist saw on the brain imaging screen the areas of the brain illuminating with activity. When we listen to music, our brains process the sound by breaking into 3 separate parts: melody, rhythm, and harmony. The brain then puts these parts back together in the split second that your brain processes it. But this of course, is only listening to music. What happens whenever a musician is creating music with their instrument? At first, the most obvious difference, of course, is they're using their fine motor skills versus just listening to something, which are controlled in both hemispheres of the brain, the left brain and the right brain. Playing an instrument involves the linguistic and mathematical precision in which the left hemisphere of the brain is involved, along with the novel and creative content that the right hemisphere excels in. Because of this, playing an instrument has been found to increase the volume and activity in our corpus callosum, the physical bridge between the 2 hemispheres. The corpus callosum allows messages to get across the brain faster and through more diverse routes. This causes musicians to solve problems more effectively and creatively in both academic and social settings. So, after discovering this, scientists then tried testing musicians as they played their instrument in an fMRI. It looks like this. So what he's actually doing, he's using mirrors to see where his fingers are, because that's the only position you can lie down in an fMRI. When they did this, their brains showed so many places lighting up that the scientists considered that playing a musical instrument is the brain's equivalent to a full body workout. When you're playing a musical instrument, your brain is simultaneously processing different information in intricate, interrelated, and astonishingly fast sequences. Researchers also discovered something amazing in musicians, that when they would play their instrument to a familiar tune while reading sheet music, that the lateral prefrontal cortex, the area of the frontal lobe that has to do with like self-monitoring, you're aware of what you're doing, and you're really sensitive to everything that's going on around you. For example, so Asher and I are going to play a piece of music that's a familiar tune to both of us, and while we're reading it, our lateral prefrontal cortexes are going to be firing billions of neurons. It's amazing. play this song with sheet music, our lateral prefrontal cortexes were being triggered and working several billion neurons, as you could obviously see. But researchers also discovered something very powerful, that there's something different about playing your instrument with structured sheet music versus improvising your music, or in other words, creating music on the spot. When musicians would improvise their music, their lateral prefrontal cortexes would actually completely shut off to where there's no activity, and their medial prefrontal cortex, which is on the screen, would turn on. In other words, the part of your brain that was so focused on what you were doing and was really sensitive to any mistakes would actually turn off. But when a musician would improvise their music, their medial prefrontal cortex would turn on, would have to do with self-expression that doesn't care if you mess up or not. And so the creative part of the brain was being more and more developed and working out like a muscle. So for example, I'm going to do that right now. Asher is going to play a couple of chords. I'm going to listen to them, and then I'm going to make something up on the spot. Pretty new. Neuroscientists believe the reason that playing a musical instrument lights up the brain on the fMRI is because it engages practically every area of the brain at once, but mostly the motor cortex, the auditory cortex, and the visual cortex. One study even showed that musicians have a significant increase in gray matter. What gray matter is, it's more neurons and neuron connections between neurons in the periolandic regions, including primary motor and some mastosensory areas, premotor areas, anterior superior parietal areas, and inferior temporal gyrus. That means nothing to you. Playing music really does a lot. So why does playing an instrument improve your brain in all these different ways? Your brain, though infinitely complex and poorly understood, is composed of approximately 80 to 100 billion neurons. These neurons throughout your whole life develop unique and specific pathways, much like a circuit board in the computer, that basically make up your personality and why you do what you do when you do it. All right? To put this into perspective, the smartest invertebrate, actually one of the most intelligent animals in the animal kingdom, has only 500 million neurons versus our 80 to 100 billion. We have 120 times more, as I'm bragging like my prideful being self. These neural pathways, go back to neural pathways, strengthen or weaken based on how often they are in use. When you repeatedly perform a task of the same occurrence, such as solving math problems, playing a video game, writing a letter, or playing an instrument, your neural pathways actually physically get larger and therefore easier to repeat and use again and again until that task becomes second nature or a habit. Your brain is also full of this thing called myelin. Going back to the myelin. To explain what myelin is in a much more simple term than it actually is, imagine the insulation or the white rubbery stuff that's wrapped around the wiring cables that charge your devices, right? The wiring is the axon or the nerve fiber, and it's the neural pathway that connects all the neurons together that sends an electrochemical signal, and then the myelin is the insulation that helps keep that signal from leaking out. The more you perform a task, the more myelin will be wrapped around the neuron pathways that correlate with that task to make the task easier the next time. So, the thicker that the myelin is wrapped around the axon of the neuron or the nerve fiber, the faster that signal will send. This is why practicing an instrument improves a large number of other skills, because it builds up myelin around the same neural pathways that these skills require. And just like going to the gym, doing a chest press doesn't make you stronger while doing that workout. It makes you stronger in everything else that involves your chest, right? So playing an instrument doesn't only strengthen your musical ability, it strengthens everything else that your brain does to perform those other tasks. So, to give you a list, performing an instrument improves, what's the word?
Memory.
I forgot. Playing an instrument improves your memory. It actually refines your time management and organizational skills. It increases skill and cooperation with others. It teaches perseverance, enhances coordination, betters your mathematical ability, gives a sense of achievement. It improves your reading and comprehension skills, just like being a kid doing this is amazing. It helps practicing responsibility and sharpens your concentration. It fosters expression. It relieves stress. It builds confidence, reduces stage fright. It develops a quick eye-hand coordination. It boosts listening skills. It requires self-discipline that becomes more and more developed. It even enhances your respiratory system. If you're a musical student, you have heard your teacher say 1,000 times, breathe. Because a lot of musicians will hold their breath and be really tight, but there's a really good breathing technique that we musicians learn to just breathe while we're playing, and it enhances our respiratory system because it's really healthy. And if you're Van Halen, then it improves your cardio. So now that we're informed about the deeper scientific explanations and reasons to why playing a musical instrument is important.
Please share this with a friend and tell them to share with their friends, and so on.
So that maybe eventually our entire community will know the importance of music and get it back in our schools. Thank you.